a webinar on the basics of it or an introduction to M&V. For those of you who can, if you can see the chat, there's links there. You should be able to see in the chat a link to Save On Energy site and a YouTube site, so you can go back and see the first webinar if you want. So my name's Eric Mazzi, and I am going to deliver a webinar today titled Low Cost M&V Options. Just a bit of background on myself. I've been doing M&V, really a lot of M&V since probably 2015, so it's getting to be a number of years. My career spans quite a bit longer than that, with a mechanical engineering background, and policy is my training, my formal training. And I've been working in demand side energy since 2007. Prior to that, I worked in consulting, maintenance, different things. So I am based here in warm but not so sunny Vancouver, British Columbia, and probably most of you are in a different time zone, which is just great. Last couple things. So I am certified, two different certifications. The CMVP is a good certification that's delivered and owned by the Association of Energy Engineers, and you can get that training through CIT, citcanada.com. The most widely used protocol is called the IPMVP, International Performance Measurement and Verification Protocol. So I am an IPMVP member. I'm also a CMVP trainer, and I do quite a bit of M&V, including and up to this morning. I had a little local site visit to do even before our webinar today, and yeah, happy to be here. Advancing my slides. Okay, so what we're going to do is not necessarily conquer the world today, but we're going to go over different approaches for low-cost M&V. So we will, first we'll actually discuss, well, how does anyone, who decides and how is it decided how much money to invest in doing M&V? Part of that is to understand when to use maybe what we'll call and define operational verification versus doing actual complete M&V. We'll go through different types of low-cost M&V methods, tools, and tips, if you will, and we'll have enough time to do a few real-world examples. So this webinar, we have 90 minutes, probably 85 minutes from now, so we should have plenty of time for some Q&A. Just for reference in the slides, there's different abbreviations that are used, and those are defined here. So the specific agenda is to go over the cost of doing or not doing M&V. We'll discuss operational verification. We'll go over a few retrofit, what would be called retrofit isolation approaches, low cost, meaning what's called option A, some sampling, and using building automation systems or energy management information systems, using that data for M&V. We'll talk about what's called a classic whole facility approach, usually using utility meters, which is option C. We have put together some low-cost metering tips, some instrumentation, and so on, and then we have a summary. Okay, we would like to learn a little bit about you folks. So we have a Mentimeter survey to start. So if you go to menti.com and you use code 45974763, which I just put in the chat. And yeah, we would like to get your survey responses here. So let's hope we get a low 20-ish number. So please go to menti.com. Yeah, 45974763. There we go. Let's see. Hopefully we get a few more folks. We got 13 going, 14, 15. Okay, so a good portion of you have an actual role in M&V. Yeah, as expected, sometimes you're in a position of hiring somebody else to do M&V. Big driver of M&V is finance, and so often utilities or green loan agencies or organizations, they're interested in M&V to know that they're getting their financial, the money is being spent wisely, let's say. Okay, so we have quite a range. So some of you, some things might be basic. For others, some of this will be completely new, and that's fine. That's kind of what we expect. One thing I'll just encourage you to keep in mind is that your role can change over time. If you're a doer of M&V, you might be hiring somebody later on in your career in the future, or if you have a general interest, maybe you're not involved in M&V yet, but you might find yourself in some role where you're part of a team, for example. So that role can change over time. So, okay, let's go back to our slides and get it set up. And okay. Okay. All right. So the cost of doing or not doing M&V. Let's talk about that. So first of all, to keep in mind, there's really a cost of not doing an M&V potentially, which is maybe there's no money out of pocket, but at the same time that you have the risk that your savings are not verified. So that's really an important thing to keep in mind. We covered in the first webinar, if you want to go back and look at it, that there's data in there, some example data, that doing M&V actually helps improve the performance of these systems, saving energy, for example. So we presented some actual sample projects based on my specific projects, but any M&V professional will probably find the same, that actually doing M&V is not just observing what happened or is happening, but the process of doing M&V provides feedback and enables corrective action, if you will, forensics, if that is a term that's used, to actually improve the system's performance. And so there's a technical piece to that, and there's a human behavior piece to that as well. So it is important to keep in mind that doing no M&V means, yeah, no out-of-pocket money, but it may not be the best overall value for the investment. So with M&V, yes, your savings can be optimized or maximized. You can also help savings persist over time. I showed data in the first webinar of a multi-year project where savings dropped after it was a project that has M&V done on an annual basis actually for 10 years. And I showed the first several years of the data that the savings were good the first year. And if anyone stopped doing M&V, you'd think, oh, okay, 400,000 kilowatt hours per year, we're good. But as M&V was done in subsequent years, then it found that it actually dropped. And those are in the first webinar. All right, so M&V and the cost. So again, the basic idea, keep in mind, there is a cost to M&V. I mean, that's a lot of what this webinar is about, is that be cognizant that M&V does incur costs for people's time, maybe out of pocket or just time out of your job. That could be done for other things, out-of-pocket costs, especially for metering and instrumentation. The basic principle is that the expected monetary savings or the monetary value of the project, the investment in M&V should be proportional to that. Something else I want to say at the beginning here is 15 or say 10 or more years ago, I would say demand side energy management was mostly about energy savings, energy efficiency. And today it's evolved where demand side energy management, and that's what we're talking about demand side meaning, hey, we're working on the customer side of a meter, like a gas meter or utility meter. It's really about energy efficiency, yes. However, it's also about decarbonization, and that decarbonization brings into other types of strategies and technologies such as distributed generation like solar PV, demand response, so saving demand, fuel switching, storage, either electricity storage or thermal storage. So all of those types of technologies and strategies have been around for decades, if not longer. However, the key idea is that those things are being employed much more at a much greater frequency, much more often and bigger scale today than it has been. And the key point is there are M&V best practices for all those things. So by default, we talk about, well, it's all about energy efficiency, energy savings, and that's still really, let's say, the bread and butter of decarbonization and demand side management. But those other types of technologies, solar PV, storage, demand response, and so on. The IPMVP and other, there are resources for all of those types of technologies and strategies, if you will. So the cost of, so what drives M&V cost? So the bar, on the right, really that lists some of the key factors. Ultimately, it's, let's say, what methods you use has some inherent costs with it. How many measures and how complex are they? What are the key idea, the funding stakeholders required accuracy. So that's a really important one, the one in the third one down. Who are the funding stakeholders in a project? Well, you're going to have the project owner, whoever owns the building or the industrial plant or the home or whatever it is. Who else might be a funding stakeholder? Well, I guess I'll let the audience speak up. Who might else be a funding stakeholder? Anybody can speak up or put something in the chat.
I would say a funding organization.
Yeah, like a loan
Like a loan or a
agency
grant program.
organization. Yeah, it's another common one. So thank you for that. Yeah. What other organization is commonly kicking in money for energy savings projects? Hint.
The government.
The government, yes. Another one, sponsor of this webinar is
IESO.
IESO. So yeah, utilities, right? Enbridge, IESO, BC Hydro, where I am, municipalities sometimes. Yeah, so whenever there's a stakeholder kicking in money, then yeah, IESO has best practices requirements. Okay, when they're kicking in money to their customers or through the local utilities, there's some strings attached to that, which means they just need to have certain requirements for the money that's contributed. So yeah, more effort, more operational verification. So the more activities and more metering, yeah, but the expectations of who's kicking in money has a lot to do with and how accurate they want to see those results. This is kind of a common sense. Okay, what M&V and cost. So the whole idea is that the more complex the process, the more M&V cost is worthwhile. That's this chart on the right. Savings over time, or savings may be a certain level, but a general guideline, this is from the IPMVP, it's kind of common sense, is that your annual, let's say if your cost of M&V would be less than 10% of the annual cost savings, or think if you were doing M&V on an annual basis, you definitely want it to be less than 10%. And that's just a general guideline. It's sort of common sense, I think. Okay, this is a list. I mean, this is my opinion, and a lot of what is in this package today is, you can interpret where things are cited and source that comes from that source, but things like this is just my judgment of what's important. So we're talking about low cost M&V, and there are certain things that for any project, if there's any level of M&V done, that really must be thought about. And in my opinion, it takes very little time to just go through, think of this as a checklist. So what are the reasons for investing in M&V? The energy efficiency measure or other decarbonization measure, if you want to look at it that way, storage or solar PV, but basic description of system, what's the system boundary for measurement, what are the key variables that might be needed for adjustments? This whole idea of adjustments was covered in the first webinar. Who's going to be the lead M&V professional for the project? Like, who's that key point person? If there's going to be any M&V activity done, there really needs to be assigned a point person. My personal opinion is that person really preferably should have some sort of one of those two certifications, CMVP or PMVA. By the way, the Efficiency Evaluation Organization has PMVA. They also have PMVE, which is an expert. So what variables are going to be metered? Do site verification. If you're going to do M&V, don't skip the site verification. Don't just assume that what was in the spec was installed as specified. I think experienced professionals will know that field changes happen. How is it going to be analyzed, and the reporting, who, how, and when. So it doesn't take more than, let's say, if you had all the relevant stakeholders involved, you could run through this list, I don't know, in an hour or something like that. So in my opinion, there's really no excuse for not thinking these things through. So before you start saying, how are things going to be done? How are we going to do M&V? Just don't go through this list. I'll just share, one anecdote. This has happened multiple times for me. Is I'm talking to colleagues, clients, other professionals. There's a project of interest, and they jump right to, well, what about option C? Should we be using option C, utility meter? And none of these questions are necessarily thought about or let alone documented. It's like, whoa, we got to back up here. Who paid for this? What are the reasons for investing? What's a description of the system, at least in some basic parameters, so on and so forth. So, all right. So operational verification. This is the V in M&V. So IPMVP provides a definition of that. So it really just has to do that verifying that the measures are installed and operating per the design intent and have the potential to generate savings. I literally did a site visit this morning. I've traditionally done a lot of industrial M&V and some commercial institutional buildings. So I've got my first residential home M&V project. So I went to a local home and I just did a site visit for this heat recovery ventilator that was commissioned on Friday. So I'm doing the M&V for natural gas consumption, indoor air quality for a pilot project working with FortisBC. So yeah, I mean, if you're going to do M&V, you need to inspect. You need to think about doing verification, and this is the purpose of it. So it's a low cost. Site verification can be a low cost procedure. You can assess the savings potential. You want to verify the equipment characteristics. What it says here is true, is that in real world experience, you'll find that field changes are common. One little story of mine, I went to do a site visit for a natural gas processing and compression plant in northeastern British Columbia several years ago. So I was working with BC Hydro. I do contract work with BC Hydro, and I'm a part of their M&V team. And the funded equipment was like two 4,500 horsepower motor-driven compressors, a 600 horsepower refrigeration unit. And so I went to inspect that, and then I met the site contact and, had to travel and all that. Go out and inspect the equipment, take images of the nameplate, go back to the control room. I'm looking at the dashboard and I say, well, wait a minute, there's three 4,500 horsepower motors and there's another refrigeration unit. And I said, well, why didn't you show me these? And it's like, oh, well, you just asked for, the two and the one there. So there was a field change and they added another 4,500 horsepower compressor. They added another 600 horsepower refrigeration unit through a field change. And it was just, if I didn't go to the site, that that fact, which turned out to be important, might have been missed. It's like, oh yeah, we just decided to add another, 5,500 horsepower in motor power that we didn't mention before. So those are the, part of the reasons, what's involved with operational verification. You want to kind of little circles on the left. You want to validate that things are installed, collect some spot readings, look at the nameplate. How does it compare to what you're expecting from the bid specs or what the manufacturer? Okay, there are certain times when you can opt for operational verification only. When you have let's say, little doubt or concerns about the outcome, there's no need to prove the results to a third party, let's say a financing party, or maybe it's just relatively small project and small savings. I mean, I've been involved with projects as small as cooking equipment on a prescriptive rebate, right? So how much M&V is worth, a rice cooker, literally, that was one of the measures. And then other projects that had, this biggest was over 300 gigawatt hour per year, 300 million kilowatt hour per year for some natural gas compression plants. So there's a wide variation. So the size of the project. I want to do a little Menti question right now. Just go back to that. And yeah, so this is talking about verification. So it's the same menti.com and the same code. So I'm going to hide the responses for a moment. All right, so this is a real project. I'm actually doing the M&V for this. It's a 14-story building, happens to have 137 suites in it, rental units, multifamily. So this building has window sensors linked to ecobee smart thermostats. And the way these work, if the windows are open for 10 minutes, then that triggers, and the heating system is running, then the thermostat will shut off the heating to that suite. So pretty basic. So let's just say site verification is done and data from an earlier pilot project is used to, let's say, verify the project. So which method is this? Now, I know many of you may not be familiar. What does option A, B, C, D mean? But many of you will, and maybe gives you motivation to go review the first webinar in this series. Let's see, we got 3 responses. I'd like just what is your opinion? So which of these 5 options is the best, you could say, method? Give it a moment. We're up to 8 responses. Up to 11. You give it another 30 seconds-ish, see if we can get more. We're up to about 30 people in the webinar. That's good. Got 14 responses, 15. Can we crack 20? All right, well, let's show the responses and talk about it. Okay. Well, at first blush, I love this because there's a wide variety of answers here, okay? Okay, I think there's very clearly a correct answer, and we talked about this and cited the source in the first webinar, and that is, this is really deemed savings. You can't really call this M&V. And we'll just talk a little bit about why that is. Okay, so if you want to, this was covered, if according to IPMVP and the IPMVP protocol, you have to measure a key variable, at least one key variable. Think of the energy of the system, or maybe it's the operating hours. We can talk about that in option A. But one of the key variables needs to be measured on the actual project that's installed. So in this project, if you use data from a pilot, from another earlier pilot from another site, that is not data on the actual system that's installed. And so that means it would be declared to be deemed savings. And there's nothing wrong with deemed savings. In fact, it's very common. A very normal thing to do is, deemed savings is fine. If you just do site verification, and there is a position statement, if you will, call it that, from Efficiency Valuation Organization, which is EVO, which is the owner of the IPMVP, and that was cited in the first webinar. If you just Google, I can put it in the chat. If you look at evoworld.org, look for what's called the MNV. I'll just put this in the chat. MNV Focus, that's their online, and also search for keyword deemed savings. Okay, so if you search for that, what I just put in the chat, you'll find it. So it's really not option A, B, C, or D, because you're not actually measuring. So the key idea is you're not measuring anything, let's say specifically the energy of the system at this 14-story building. And the other key message is site verification is really valuable. However, according to EVO, site verification alone, that's the V of M&V, but it's not technically M&V. And so this situation would be commonly described as a deemed savings, not actually one of the methods. Right, let me get back to our PowerPoint, switch things around. My dashboard set up. Okay. All right, so operational verification, again, very important. If you're going to do an actual complete M&V project of any type, well, that includes the V. That means you need to do the verify. So what's involved is usually, obviously, visual inspection, sample spot readings, short-term performance testing, or maybe there's data historians in an industrial plant, building automation systems, in a building where you can look at trend data over time, review trend logic, things of that nature. So as an example, for say a lighting system, you can count the number of fixtures, show you a little image coming up later where I did the light site inspection for one of the BC Hydro projects. You might verify that controls are calibrated and functioning correctly. Similar types of thing for any kind of HVAC upgrades is you want to look at nameplates, you want to check temperatures, check set points, things of that nature. I literally did that this morning for a little mini project, heat recovery ventilator. I did spot readings of temperatures. I took images of the nameplates. By the way, and I knew this was coming, it's a different HRV than was spec'd originally, because the original one would not fit in this residential home furnace room. And similarly for water conservation measures, and by the way, IPMVP also, as comes mentioned later, there are other M&V protocols, and ASHRAE has a good one, ASHRAE 14-2023, and it covers energy and water savings. So you would just want to confirm the water saving devices, do the counts, check that what is installed is. You might check the water consumption data if you have it. Okay, there's operational verification templates. So for this, see its support with IESO, there's a handful of templates. One of them is an operational verification template. And the links, the Save on Energy link that Melis put in the chat is, I believe you can go to that link and scroll down and look around there, and you should be able to get this template. Is that right, Melis?
Yes,
Probably.
but not yet. It will
Not
be
yet.
up there shortly. I'm going to put the link again for future
okay.
reference.
Thank you. Yeah. Okay, so now we'll move in and talk a bit about retrofit isolation. Maybe I'll just pause. Any questions or comments so far? Feel free to raise your hand or put something in the chat if a thought comes to you. Questions, comments? Okay. All right. So we're going to talk about 3 common low-cost approaches for retrofit isolations. Again, the theme of this today is everything's about, well, what is low cost? And so we'll talk about what's called IPMVP option A. We'll talk a bit about sampling and use of building automation or energy management information system data. All right, so option A, and for by way of review, if you don't know what option A, B, C, D means, you can go review the IPMVP. We have links to resources at the end of this slide presentation. So you can get the IPMVP free. You just go to evoworld.org, you set up a username and a password, you get yourself a free account, and you can download their protocols and their best practices guide, including the core concepts. It's just part of the world. I know when I started working in M&V, it's a little just like a lot of areas of specialization, that there's their own language and terminology. And if you're hanging around with people doing M&V, they're saying, "Oh, that was an option B. We should have done an option D." Well, what does that mean? Well, it's kind of jargon specific to the M&V world. So option A, and there's also option B, are retrofit isolation methods, which the name kind of implies what you're doing. So option A is the lower cost approach for doing retrofit isolation according to IPMVP, and similar. ASHRAE and many other protocols essentially have the same approaches. So with option A, you would just identify the critical variables, more specifically, the lead M&V professional who is designated for the project will have the key role in identifying and, let's say, deciding which variables are critical and which are not. But it's usually your energy variables, maybe your operating time. But with the idea is these key parameters are critical variables. You would only measure it. You would measure at least one of those to be according to IPMVP to be able to call it an option A. And so you want to think about on a project, as we already mentioned, your measurement boundary. What variables will change your energy consumption? And any change in these variables is a key parameter or a key driver. So the occupancy of a building, the outdoor air temperature or weather, the production volume in an industrial plant. These are just common variables where if any of these variables change substantially, then it will change the performance and energy consumption of your system. So you really want to identify those key parameters and measure them, or at least some of them. Okay, some other ideas about option A. Some key parameters will be measured, others can be stipulated. We'll see an example with a lighting project coming up. The more variation in the project, the more variation in the process, whether it's an HVAC process or an industrial process or a simple ventilation process in a home, the more the process varies, the more measurements you need to do, and the more complex and variable the process, the less likely you would use option A. Actually, you of course want to measure before and after. You want to think about energy consumption, operating time, and we'll see that through some examples. So again, other examples of key parameters. So for lighting, the very classic application for option A is lighting system, where you would either measure the bulb wattage, the watts, or you would measure the operating hours, but not both, because you're trying to balance the cost of M&V. So we have one example coming up. For a motor, let's say an industrial plant, key parameters would obviously be the flow, probably the pressure, suction, discharge, common for a pump. Electric power, operation hours. You may get by with measuring maybe only one of the key parameters, like power or hours of operation for a lighting. So here's a an example, just very summary of a key parameter measurement approach, which is very common. So let's say you have a production plant and you have a lot of linear fluorescent lamps that are going to be replaced with LEDs. So there's an operating schedule for that, hours per day, 350 days per year. And so the key parameter that's going to be measured here would be lamp wattage. The stipulated would be hours of operation. So it means you would not necessarily meter the actual operating hours. You would do some measurements of wattage. And again, that's a money saving decision. So in this case, you measure the power before and after. You get so many watts per lamp, and you just do the math times number of lamps and operating hours, and you get your electricity savings. As I've already mentioned, there's similar to the verification template, there is a lighting template that will be available on that Save on Energy website. So it's in the spreadsheet form. So especially if you're relatively new or haven't really embarked on M&V yet, you might find these templates especially helpful. For those who are more veterans, maybe there's some tips there that are useful, but you might have your own tools already. Okay, another example, this is based on an actual project where there were 47 end uses motor driven. They were all, so a full retrofit isolation approach would meter all of these motors in the list. So you can kind of see it in small print there, but motors ranging from 500 horsepower nameplate to 200. So in the interest of saving cost, a sampling approach was done where power was measured continuously on 12 motors. And in summary, how it worked, we're not given the full, is we were following, I did this project, but there is a sampling reference guide. So Evo has some sampling M&V guidelines. And just to give you another resource, which is mentioned later at the end of this presentation, Bonneville Power Authority in the US has some great M&V resources. One of those resources is they have a sampling for M&V reference guide. So I've used this, my colleagues at BC Hydro have used this. The short story, we're not getting into the details, but the whole idea is you can use a sampling approach, and that saves money versus measuring all 47 motors. So we took motors representative of 3 different groups, and we determined the savings based on a sample of each of those 3 groups. And then we multiplied out, we assumed the savings for the measured motors within each group applied to each group, group 1, group 2, group 3. So that was the basic approach. So yeah. So there are other types of projects where M&V, where sampling is done. Let's say a building with multiple air handling units, kind of illustrated on the left. Lighting is another very common application where sampling makes sense. The one on the right is a very large sawmill that I did a site inspection, and it had hundreds of new LED fixtures between all the buildings in this plant. And of course, any M&V, it would not be cost effective to do all of them, and especially if you have hundreds of lamps of that you would do a grouping and sampling approach would be definitely the most cost effective for that. Okay, let's talk about using building automation system data or energy management information systems, EMIS. So this is another example of, I'm actually involved in a project supporting a client doing exactly that, where they're using building automation, energy management information set data for low cost M&V. It happens to be Kaizen and this building automation system called IntelliWeb. As no surprise, we're not here to promote any specific companies. They happen to be the ones, and there's a very long, long list of EMIS and building automation system companies. So this is just a snapshot many of you will probably see very often, which is a rooftop unit RTU-1 shown on the right. And of course, you look in the middle and there you can see 7.2 amps for this one fan. You can see 0 amps for a couple of other fans. So you get process data, you get energy data from building automation systems, or maybe it's on an EMIS dashboard. And that's real data that can be used for M&V, and it is done. Just to give a few tips, this is the actual calculation. So in the black is the data that comes out of the Kaizen system in this case. And in the blue are just some sample M&V calculations. And one of the issues that came up here is in the BAS and EMIS systems, neither of those actually has listed the motor nameplates. So this project, just to illustrate as one example, is all about using the BAS data and which connects to this energy management system. Well, nowhere in there does it list even, it's all about electrical savings, so they're not doing gas through this. But the actual motor nameplate data is not in the system. And the people doing the M&V for this do not actually know the nameplate. And so what my recommendation and what is being done is they're just sending someone out to the site for, when practically speaking, it's only going to take a couple of hours for a municipal facility, and just verify the nameplates and the capacities of the equipment that's for which M&V is being done. So this is an example. If you go back to that must list at the beginning of this webinar, you don't want to skip. You don't want to skip. You want to get a basic information on the equipment and the systems for which you're doing M&V. And it might be subtle, but in this case, it can be very easy to just start getting data from, let's say, Kaizen, and start calculating numbers and savings without even knowing what the motor nameplate horsepower is, or the motor rating. So what might be the downside if you don't know the rating capacity of your motors? That's a question for anybody, if you want to raise your hand or speak up. Like, what's the downside of analyzing data for savings when you don't necessarily, if you don't even know the motor nameplate? Just what can you think of? What could go wrong with that? Anybody?
Well, the data you calculate would be incorrect at that point. You wouldn't have a accurate benchmark to compare to.
Yeah, it could be incorrect. You wouldn't necessarily know, like, we see this all the time. I saw data yesterday that sometimes the number that comes up in your data historian is so large that it's impossible for that equipment to have consumed that much power, let's say. And you won't know that if you get an outlier reading that's just a manifestation of beyond the scope of this webinar. But data systems, there's an instrument or a sensor somewhere, and then there's communication system and data processing. So in the communication processing, so there can be errors at multiple points, either the sensor, the log, the recording of the data, the communication from the sensor to wherever it's being logged. Some people either automatically or manually modify data, and you can end up with outliers that make no sense whatsoever. And if you don't have at least basic understanding or documentation of what the system is and how it works, you may not recognize outliers, and you could just start working with numbers that have no basis in reality. So before we move off using, I want to talk about a little bit the idea of using building automation or energy management data for M&V is very much related to what's called advanced M&V. So I'm just sharing with you this M&V Focus, which is a sort of a quarterly, not quarterly, but I think maybe twice a year newsletter that the EVO puts out. And one of them, there's a link here about advanced measurement and verification. And one of the practice guides that you can get for free, this is a white paper written by a colleague of mine, Leah. It's also on the IPMVP. This was published in 2020, but it's this is a white paper on advanced M&V and what it is. the reason I mentioned is that a key part of M&V, I mean, it's related to using building automation system data or maybe industrial data historians, data that's collected ongoing and real time so that you can do, let's say, somewhat automated and somewhat real time measurement and verification. So I just want to mention that. So it is potentially fits under the idea of a low cost method. So I just want to, there's a whole world there within M&V, or a specialization with M&V on advanced M&V, or sometimes you might see it called M&V 2.0. I'm kind of highlighting here. So you might just want to be aware of those methods. Part of me sharing it is just also to remind you that, yeah, you can get lots of free resources from EvoWorld. Okay, so we'll talk a little about option C. So a classic option C is to use the utility meter. So this is M&V for a medical office in the Southeast US. This is also a project of mine, but so I looked at natural gas savings. There were two different programs involved. One was a behavior change program that focused on operation and maintenance practices. And there was also a utility-funded recommissioning project that happened to be going on at the same time. That's important to know because often whoever's funding the program, they want to know what their savings are attributable to their program. So in this case, the behavior change program funder would like to know, well, if we're seeing savings, how much is due to our interventions, meaning our training, our operating procedures, so on and so forth. And then the recommissioning folks would also like to know, well, how much is saved due to what we did and the activities we undertook to do recommissioning and all the documentation in that. And yeah, so that's important. And ultimately, for this specific project, we could not distinguish between the two, but that's sort of a common event that happens. So in this case, whole facility, we use monthly utility data from the natural gas utility. Those of you who have experience with option C or using utility data, you'll know this. Those of you who are new, the basic idea is you build a regression model for the baseline system, which means the building before the retrofit was done. And in this case, you're using outdoor air temperature in the form of heating degree day values. If you don't know what that is, we'll talk during Q&A or something, but the basic idea is you use a model of the baseline building and the baseline pre-retrofit consumption, and then you project what the facility would have consumed during what's called the M&V reporting period, which is the post period. You have certain model statistics that help you decide whether that model is acceptable or not. And then you project the savings. So that's a common option C approach. It's low cost because utility data is usually available anyway. It's already been paid for. I will mention there are cases where, especially for natural gas, you get monthly data as part of the utility account holder gets for free. But if you want daily data, it's often available, specifically if the building or facility or the account has a demand charge, a natural gas demand charge. The utility will have very likely the daily gas data, but you have to pay for it. But that can still be considered low cost. So in this case, you compare the consumption, what would have happened with the baseline model to what was actually recorded with the utility meter, and it was a 6610 savings per year, which was about 8% of baseline. The non-routine adjustments were heating degree days, and we did not identify any of what are called non-routine adjustments. Okay, our last portion here is to cover some low-cost metering tips.
Eric, before we move on, I think there's
Yeah.
a question in the chat that might be relevant to address before
Oh,
we
yeah, thank you.
go to something else. So the
Yes, thank
question
you.
is, can the baseline of option C be a calibrated energy model rather than regression in case we can't get a valid regression correlation for the baseline period?
I guess the answer is, of course, absolutely. You can use a calibrated energy model like I don't know, Hot 2000 for a home, or what, IE4. There's many modeling. You can use that in the M&V world. That would be classified as an option D rather than option C. But yeah, absolutely, you can use a calibrated energy model rather than regression model for sure. It just probably would not be called option C. And by the way, the labeling, I know this comes up often, and let's say on the IPMVP committee, there's pretty much consensus. The labeling of whether it's option A, B, C, or D, at least by the IPMVP committee and the individuals, myself included, it's not that critical. There's a lot of projects I would describe as probably hybrid methods of option B and option, like you're using some retrofit isolation measurements and you're doing some modeling. So very often I would describe a project as a hybrid approach of option B and option D, as in DOG, which is computer simulation. I mean, if you're using whole facility data and some calibrated model, I would say probably that's better. If you have to label it, label it as option C and D hybrid, which to me is just fine, and many of my colleagues. It does seem, yeah. Anyway, another story is that for certain funding stakeholders, sometimes the label that's assigned to the M&V is important. and they might say, we want to know, is this really an option, a valid option C, or is this an option A or B? It seems to be important to some stakeholders at times for good reasons. And sometimes it's not so clear what to label it, and there's judgment involved. Yeah, good question. Thank you. Yeah, the idea that judgment is pretty much always involved. I mean, some projects are pretty straightforward and not too much controversy. Many projects, I mean, M&V it came about over disputes over money, which historically, and so M&V is strongly linked to financing of efficiency and other related projects such as distributed generation. And so when there's money exchanged, and that's why M&V is important. It's to validate, hey, are we getting what we paid for, or an ESCO contract, energy services contract. Anyway, so part of it is there's always judgment involved. And the part of the point I want to make, it comes back to what I said earlier, that it's really important to have a designated M&V professional. I've come to believe, and I'm not just promoting these certifications, that I mean, experience is critical. Certification is very helpful, and I would say if the person who's the designated M&V professional, there's really no excuse for that person not to find somebody who's certified, because there's a lot. I guess I'm pretty sure you can go to CIT Canada and find out who is CMVP certified, for example. You can go to Evo World and probably find out who's PMVA or PMVE certified. I guess by show of hands, anybody certified who's attending today? Either CMVP, PMVA, PMVE, anybody? Got a couple people, a few people, 3, 4. Okay, there you go. All right, let's cover some low-cost metering tips. So this slide is about, sometimes runtime is a key variable that you can't, especially in building systems and industrial plants. Often there's instrumentation, built into the instrumentation and control system. Now, how well calibrated it is may be another question, but you can usually get it. In buildings in particular, or especially older buildings, buildings with no BAS system, you don't have data on, you can't even tell runtime. So you can look at an HVAC motor, like open up an air handling unit, see a nameplate, but you can't tell what the motor loading is. You don't know how many hours it operates. So operating hours, for example, is a key variable, and a low-cost method is just to use loggers. Now, I see a hand raised. Is that a question, or is that from my little impromptu survey? Andrew? You have a question? Is good? No?
I think I put my hand down.
Oh, okay.
Okay.
And then, Monica, you had your hand up. Do you have a question?
Hi,
Which
I
is fine.
do. I'm actually from the ISO. My counterpart
Great.
was one who was working on this presentation, but I just wanted to bring up that for anybody who's not certified as a CMVP or PMVA, we actually have incentives for up to 50% of the courses on our website. I'm going to put the link in the chat. I wasn't sure if it was in the presentation. I just wanted to share that with everybody. Thank you.
Excellent. Thank you, Monica. Okay. All right. So this is just illustrating. So on the left are lighting on-time loggers. And actually, a colleague told me Dent no longer is selling those Dent loggers. So I just tried to put a couple that I've seen on projects, but apparently Dent has discontinued. So sorry about that one there. In the middle, there are lighting intensity loggers that this is just a sample of relatively low cost instruments that can provide valuable information. On the right, that's a little motor on-off logger that I'm using for a project. It detects the magnetic flux for an induction motor. It's got little magnets. It just sticks on the motor and it records runtime. And especially if you've got, you know, a 5 horsepower fan motor in an air handling unit on the roof somewhere, older building, you won't have runtime. A little anecdote, you can also talk to operating staff or get indicators of runtime. From my experience, I've done audits and projects involving where there were no building automation system. The verbally reported operating time did not necessarily match up with the data. So having actual measured data helps. And these loggers are, you know, usually just like 200 Canadian or less, I think. I bought some of the onset ones recently, you know, on that order. And then, of course, can be reused on multiple projects. Electric submetering. So this is an example where if you had a larger system, you want to use a 3-phase power meter. So Dent, this is one that's commonly used in systems. Just to share, one of my colleagues shared a couple tidbits, and well, let's just say a credible, I'll just add a few notes here, source of mine says that these are about $1,600 to purchase. I'm assuming this is going to be even one, I don't know the capacity, but this is going to be, you know, probably on the order of, you know, even for up to like a 500 horsepower motor or larger. I didn't get it. And then it's probably going to be probably about, at least for an experienced ticketed electrician needs to install this. It's about, you know, 2-hour install, you know, 2-hour remove, you know, just to give some ballpark numbers around what this might cost. Let me switch this back. So, I mean, this could be seen, if this is a very small motor with a low value, this can be way too much money than is considered to be worthwhile. However, in many projects, this is quite reasonable because especially this instrumentation can be reused on multiple projects. So, you know, for, I don't know, $2,500, you can get real power on measurements and have it logged. So I'll talk a little bit about natural gas submetering because especially, well, my experience with buildings is it's pretty uncommon to have natural gas submeters, say on heating boilers, domestic hot water boilers. In industrial plants, when there's natural gas submetering, it's often old and of unknown accuracy, and usually flow meters drift a lot over time. And so to do M&V for natural gas or any other gas fuels, you want to consider maybe getting some temporary metering. So this is just a tip that these insertion meters, and this is actually showing Sage is the manufacturer, but there's other. I've got another project where Onicon meters are being purchased. Just to mention, there's multiple, and there's more suppliers than that. Onicon is another one. So with these insertion meters, the whole idea is you can get it set up so that the meter can be inserted. You can do your M&V, and then it can, as long as it's set up, just following like the sketch on the right, and a common practice is you can remove that meter without having to shut off the equipment and just have it safely isolated, and you can go use that meter on another installation. So even for commissioning, or if you're just doing 1 year of M&V on a new system that maybe put in condensing boilers, or this is actually not this manufacturer, but a different is being used for some natural gas absorption heat pumps, for which I'm doing M&V. So I found it's a real challenge. The other thing to mention for natural gas is, unless you're working with like upstream natural gas systems, very high pressure, such as near the fracking site where I've done projects, there are no strap-on non-intrusive gas meter technology that work for facilities. So what the manufacturer's specs that I've looked at, and I've talked to a number, you need 25 atmospheres of gas pressure, 25 times, let's say, 14.7 psi, whatever that number is, hundreds of psi pressure for non-intrusive natural gas flow meters to work. And of course, in buildings, industrial plants, even at the facility scale, you're usually really, you're at low kPa or low inches of water pressure, or at most a couple of psi. So non-intrusive strap-on doesn't work like it can do with, say, BTU or thermal meters. So these insertion meters are a little tip there. Some resources. So U.S. Department of Energy has a best practices guide from 2015. That seems to be the latest version of this that's available. I checked past couple of weeks. So it has a lot of resources there. It's still very relevant, not necessarily a lot of things that's changed in 9 years. The ASHRAE, pardon me, I'm gonna get a drink of water. The ASHRAE 14-23 M&V protocol, in the appendix, there's a few little snippets there. There's a summary of different types of metering. So there's a little snippet there of flow, electric, and gas meters, and there's more than that as well. So there's another resource you might want to look into. And by the way, we're speaking of ASHRAE 14. There's free versions, especially the ASHRAE 14-2002. You can get free on the internet. I don't recommend using a 20-year-old protocol. I would pay the $100 and get the 2023 version. There's also a 2014 version, which is now outdated. 2023 is the current version. Okay, so that wraps up some of the key points. Are that the project funding stakeholders, so the owners, financiers, who's ever kicking in, let's say, rebates or incentives. Those are the ESCOs, right? They will have, they're involved in deciding, well, what's the purpose of M&V? How accurate is it needed? And ultimately, how much investment in M&V is worthwhile? So you can consider operational verification only, and let's say stipulated or deemed savings, and that's fine. Keep in mind, if that's your only function, certainly according to efficiency evaluation organization, you can't legitimately call that M&V, just the V. So yeah, there are operational verification plus lower cost methods we've talked about, like option A, using sampling, using utility meter, using building automation, EMIS data. And then we talked about a few tips on low cost metering for things like time, electricity, and natural gas flow. 2 free resources I've already mentioned. This just provides a little more, but at evoworld.org or bpa.gov, you can get some free resources. ASHRAE is another great resource. Unfortunately, it's not free, but it's not too expensive either. And yeah, we can, I've got some, yeah, we can do some discussion. I've got maybe some Menti questions that maybe we could use to spur a little discussion too. So I think we have over 20 minutes, and welcome questions. No questions? Okay, well, are you sure? Let's see. Let's see what we have here.
Maybe I'll get it rolling, Eric. I'll ask you a
Yeah.
quick question. So regarding these low-cost metering tips and the types of instruments that you showed us, which one would you say is the one logger or metering device that you find most useful?
Yeah, great question. Still, it come back to me, it's worth emphasizing, is kind of back to this slide, which is, okay, what are the reasons for investing in M&V? I guess there's maybe an obvious question missing here. Describe the system. What are the key variables? How much accuracy is needed? Is the site verification done? Who's going to do it? But the short answer for the cost, the best answer is it depends. But I would say runtime loggers for your money in a lot of, especially buildings. I've done a lot of industrial M&V, and it's not particularly an issue. But especially in buildings, or maybe including residential, the smaller the facilities, just getting runtime is, especially for electricity and lighting, or motors and lighting, which cover a very high proportion of electric consumption in any building. Just getting that runtime. I can even mention some industrial applications like infrared heaters in, you see these, let's say, usually natural gas fired tubular heaters or infrared heaters for industrial plants or assembly plants. They'll often be kind of mounted up high, radiating heat onto the workers in the space. You can put runtime logger on the combustion air fan for a couple $100 and you can get operating time. Now, one of the practical things, you need some way to get a lift up so you can actually access the combustion motor or commercial boiler. You can put that on, so this 14-story multifamily building I'm doing M&V, it has one old boiler there. And of course, there's no building automation system. And I'm not doing it because I don't need it, but I could just put a timer, one of these loggers like on the right, on the combustion air fan of that boiler, and I could get boiler runtime like very accurately, because when the boiler kicks on, it has to have air to fire fuel. And the air is always, so metering fuel is more expensive and makes more investment, but even just getting runtime, that reduces a lot of the uncertainty. So yeah, I guess that's my my best answer to that question.
I think it's a great tidbit of information, that some things are hard to measure or costly to measure, whether it be fuel or electricity related, and using a proxy like runtime can be almost just as effective while being a lot less costly.
Yeah,
for sure.
Yeah. I mean, the other key thing is what's the load. So for a boiler, if you know the runtime, that's kind of half your problem. That's really, and it's kind of easy, potentially. What the boiler load is, like, is it running at what percent of the full firing rate? Yeah, you might need to get that from, sometimes, I didn't talk about BTU meters, but BTU meters are another common kind of meter. I could actually, yeah, maybe I'll just show you a project just to spur some conversation here. I think I've got, yes. So this is one that's being used on this other project. So it's a clamp-on BTU meter. So it really gets water flow and 2 temperatures, like your supply return temperature. So that gives your BTU, if you will, they just thermal energy. Because it's strap-on, it can be used on multiple projects. So where would that be useful? Well, there's a lot of it depends. I mean, if you're part of a consultant that does M&V, you're going to have multiple projects over time. You can reuse this instrumentation. If you're working on a healthcare campus or a municipality or an educational campus, a school or university, you're going to have multiple buildings. And investing in some instrumentation like this can you can think ahead that it's useful over time. I guess that's the other part of what's low cost and what's justified. And we did talk about this in the first webinar, which is instrumentation. That's the investment of instrumentation for M&V can often be converted and linked to, let's say, an energy management information system to be used after the so-called M&V is done. And this is another example where this BTU meter is actually going to be connected to the DDC system. Think of the building automation system. And it's going to be monitored over time with 15-minute data. And that can just stay ongoing as to manage and monitor the performance of that building for multiple years. Or it's
Great.
strap on and it can be reused somewhere else. So it's kind of another metering tip.
There's a question in the chat. What is the best M&V strategy to verify energy savings achieved through energy efficiency employee engagement and awareness campaign?
Yeah, thank you. That's a great question. So the one healthcare facility I was involved in, it was a behavior change program. So it was exactly that, I would say. Employee engagement, awareness. So what that involved, I can share. It was Atrium Healthcare. There's actually publications. If people are interested, you can email me. My email's in the presentation, and I'll put it in the chat as well. Yeah, the best. I mean, probably option C. When you have these awareness campaigns and engagement and training, that all falls under, let's say, behavior change. And by the way, those, strategic energy management, I'm sure many of you have heard of SEM. It might be that I think ISO had or maybe still has SEM, Strategic Energy Management Program funding and support. It's a very common approach. So that, to me and other experts that I respect, consider that a behavior change program. The idea with those is you can't really use retrofit isolation because you don't know exactly what changes necessarily are done. You don't necessarily have records to isolate systems. So if you do training for HVAC technicians, like I saw and participated in with it's Atrium Healthcare in the Southeast US. When these workers get training and then they're encouraged to do things, all sorts of things, operational set points, resolving hot cold complaints and system fixes, doing maintenance activities. It's that project made a lot of effort to record those activities, but in general, it's very hard to record that. And so you're really left with trying to look at whole facility changes. And in fact, I know strategic energy management uses building modeling or facility level modeling, which probably is best described as option C. Yeah. Let's look at another question. How to quantify implementation of a BTU or water meter as an energy saving strategy? Yeah, it's that's Karan has a question. So water meter, which is part of a BTU meter. So for what's called sensible, so you're just heating or cooling water. So you can use, if you're familiar with like specific heat times change in temperature, and all you need is mass flow, change in temperature. And so you can readily do these. If you meter water flow, hot water flow, chilled water flow, and you get two temperatures, supply and return, you can get how much thermal energy is input to hot water or extracted from chilled water and so on. So that's the, I don't know if I'm answering, but the value of it is to get the thermal energy that, let's say, is, in cooling energy delivered by a chilled water system, or heating energy delivered by a heating system. And the value of that is, let's say, like we're using that Onacon meter that I showed you for the hot water, the hydronic water. And you can use that, and you can use boiler efficiency data, and you can fairly accurately quantify your input fuel. The other little nuance there to your question, Karan, is that if you get some sort of continuous monitoring of your water flows, say chilled water or hot water, then then you can get really more of like a continuous an estimate of your continuous fuel consumption for cheaper than you could get with a gas meter. Because you can readily quantify boiler efficiency just by doing some spot readings or using the manufacturer spec. So, like, yeah, like anyway, I could show you. I just did some. Even I can do it. Which another tip for boiler efficiency, I can tell you. Yeah, I used a. We'll get to the other questions. It was what was it? It was Testo 310 combustion meter. I just bought one of these for about 1,000 Canadian dollars. So the price has really come down. I guess that's another metering tip is traditionally, I actually got mine for 1,000. I don't know this, but yeah, it traditionally these have been much more expensive than about $1,000. And you can use that to get to measure your combustion efficiency, which is essentially your thermal efficiency. And yeah, and it doesn't take, I mean, trust me, I'm not, I did a lot of measurement like 30 years ago, but working in a desk and getting a PhD and stuff does not help you operate one of these analyzers. I'll tell you from experience. They're very easy to use and low cost. Let's see. Yeah, this is being recorded.
You have a couple more questions, Eric.
Yeah.
There's one about option D. When would you recommend using option D in retrofit projects?
Yeah, so option D, okay, first of all, option D is usually not considered low cost. And the reason, usually, I mean, these are somewhat subjective, but modeling costs, so to hire a competent modeling professional, modeling engineer, the software involved, and get it done accurately, it's usually pretty expensive. Meaning, what is expensive? Well, expensive is relative to the value, but when I've done some work where I had to hire modelers. I mean, for say a commercial institutional building, and if you want it done, let's say right, or it would be, you're probably starting at like $25,000 just to have modeling done. I've been involved in a lot of industrial projects, working because I work in the industrial team for BC Hydro's M&V group. Pipe Flow or Schlumberger has it's a company that has specialized software for all sorts of like natural gas compression. Again, you're starting in probably $20,000-$30,000 and up just to get some competent professional, usually an engineer, to model these systems. So okay, so to answer the question directly, the classic answer to when would option D be used in retrofit project. Ultimately, if it's new construction, so your baseline system is usually described as hypothetical, that baseline building that would have been built to minimum code requirement versus a more efficient building or more low carbon building that was actually built. The baseline building never existed, so you can only analyze it in a model. Same for new industrial plants, new nitrogen liquefaction plant, new natural gas processing plant. The baseline option, the less efficient, was never built, so you need to there's no baseline system, no baseline data, so you have to simulate it. The other is if you have an old facility where there actually was a baseline system, let's say an old boiler, but there's no data available. Data was not recorded, it's not available, so you have no baseline data. And so that's when you would use option D. So new construction or where there's no baseline data available. The other question, what's the best M&V option for slow buffer loggers? I'm sorry, my ignorance here. What's a slow buffer logger? And by me asking that, I probably don't have a good answer to be. Maybe Melis can help out. I'm not sure.
Sorry. When the meter does not record the data in time, kind of slow.
Sorry, the sound wasn't working too well on my end.
I said when the meter is not recording the data in real time, it's more like it's slow.
Oh, in real time. Okay.
Yes.
What's the best evidence for? Well, it's probably going to be an option or a retrofit isolation method. It reminds me, if you're doing real-time logging and kind of real-time M&V, that is essentially the definition of advanced M&V or M&V 2.0. And I mentioned those earlier. I'm kind of showing, there might even be a more recent publication than this, but yeah, like the other thing, like Evo has, I think it's probably mentioned in here. Yeah, M&V, advanced M&V or M&V 2.0. If you're talking about real or near real time logging and M&V, that's what it is. And there's lots of guidance about when to do it, how to do it. My other comment about that is I know, like at least in the US, it's pretty well quantified what they call their CBEX survey or Commercial Building Energy Survey in the US. I don't have the number at my fingertips, but a very high proportion of what are called small commercial buildings, which I think they cut off at 50,000 square feet, a very high percent do not have building automation system, like 80% or higher. And I'm pretty sure the same is true here in Canada. There might be some NRCan stats. So my point is, advanced M&V or M&V 2.0, you need a certain infrastructure to be able to do that. If you're talking slow buffer loggers, advanced M&V, real-time data collection, I mean, data means you have sensors, instruments, you have an idea of the accuracy of those, you have a decent inventory or system description. And that type of infrastructure tends to be available in new buildings or buildings that have undergone, let's say, substantial upgrades or just maybe have been exceptionally well maintained. But in the world of buildings, that can be somewhat rare. Even for industrial plants, it's very often that instrumentation and as-built records can be quite outdated. Of unknown calibration. That's another little tip. If you're using plant instrumentation in an industrial plant, I encourage you to ask the often unpopular question of, do you have a calibration record for that? Just ask nicely and softly, but because often it's like, why are you being a troublemaker asking me for my calibration record? Anyway.
Yeah, maybe if I can chime in also, Eric. If the question is like if you don't have real-time data and maybe the data is not available right away, or it's available on a daily basis or something like that, that's not a problem for conducting MNV. We can always get the data and kind of consolidate it later in time and conduct MNV with that. It does not need to be real time to do things like option A, option C. We can have different formats of data to do that. I'm not sure if that answers the question.
Okay, it does. It does.
Okay.
Yeah.
We're 2 minutes away from the end of our webinar. I don't see any other questions, but now is your last chance. If there are no other questions, thank you, Eric, for the very informative presentation today. And I wanted to ask everybody one last question before you leave. If you can put in the chat, what are your MNV needs, or is there anything specific that you would want to see in this webinar or resources in the future? We are looking to put more of these together, and we want them to be useful to everyone. So if there's anything specific you want to hear from us, please leave it in the chat before you go. Thank you, everyone.